Good morning, students. Welcome to the SourceForce e-learning session of Physics Grade 8. SourceForce is one of the leading names which has their students in life coach through schooling, sports and life skills. Now today we are learning about the physics first lesson, that is matter, and from this lesson today we are learning about what are the three states of matter, explain their properties, their postulates of kinetic theory of matter, and find the differences between the evaporation and boiling. Make a list of processes involved in change of state of matter. So now we will go through a quick revision. Okay, still last year what we have devised, what we have learned, on that basis this is a quick exercise we will do. You have studied about matter and its state in your previous classes. Now look at these diagrams. These are, okay, you can see here. The first diagram, second diagram and third diagram. These are the three states of matter. Okay, now what is this from there? From its molecular arrangement we can understand about the state of matter. First is a solid. Okay, now next quickly move to the next one. What is this? The arrangement of molecules are little far away from each other. Oh, must be it is a liquid. Now let's move to the third one. Here the molecules are very far from each other as compared to the solid and the liquid. It is a gaseous state. Gaseous state, correct. So how many states of matter? Solid, liquid and gases. But actually tell me, what is the matter? The definition of matter is anything that has mass and occupies space. It is called as matter. Very good, students. Now, smallest possible units of matter that show all the properties of matter. Each matter is made up of very small particles, correct? Atoms and molecules. So what is the smallest possible units of matter that exhibits all the properties of matter? Yes, this is atom. Now, the amount of matter that present in an object is known as mass. Oh, now state of matter that can be compressed easily. You can see here solid. There is no space in the molecules. So it is very hard to compress. Liquid is having little bit space between the molecular arrangements. But in the gases, there are lots of space between the molecules. So that's why they can be easily compressed. So tell me, the state of matter that can be compressed easily? Exactly, that is a gaseous state. Very good, students. Now let's move it to our next point, and we have done through our today's introduction and the revision. Oh, so from this lesson today we are learning about the intermolecular space. What is the intermolecular space? The space between the molecules of a substance. It's very easy to understand. Okay, from the previous page like this, we can understand here in the solid state, no space. Liquid having more space compared with the solid, and the gaseous is having more intermolecular space. What is the exactly intermolecular space? The space between the molecules, correct? The space between the molecules is known as intermolecular space. Now the next is intermolecular force of attraction. What is the next term that we are learning today? This is intermolecular force of attraction. Intermolecular force of attraction, that is, molecules of a substance are attracted towards each other by a force of attraction, is known as intermolecular force of attraction. Means what? The molecules are having the force of attraction between them, and this force of attraction is known as intermolecular force of attraction. The third point we are learning, that is the intermolecular space. Oh, is it increasing and decreasing? We have to learn it about that. Intermolecular space. The increase in intermolecular space between the molecules leads to the decrease in intermolecular force of attraction, and vice versa. Correct. Means the increase in intermolecular space between the molecules leads to the decrease in intermolecular force of attraction, and vice versa. How it is possible? Okay, we will just go through the example. From this diagram, what you can get to know about this here, the solid matter. Okay, state of matter is solid. Here less attraction. No, its attraction is more as compared to the solid, liquid and the gases. Very less space in the molecule. So the force of attraction here is the force of attraction between the solid molecules is most as comparatively with the liquid and the gaseous state. And the liquid state, there is a more intermolecular space is present. That's why the intermolecular force of attraction is less compared to the solid. And in the gaseous state, the attraction between the molecule is less, and the force of attraction is very less. Okay, why? Because the intermolecular space is more. So what is the nature of molecule? What is the nature of molecule? Cohesion and addition. What is the meaning of the cohesion and addition? Okay. Force developed between the molecules of a same material is called cohesive force, and the force developed between molecules of different materials is called adhesive force. Here, see these two brothers, picture of these two brothers. These are in the blue color. They are having a force of cohesion, but one is in green color and another is in blue color. So you can see here they are having an adhesive force. With the example, you can see here addition and cohesion. The force of addition is more between the two different molecules of a two different molecules, okay, and of the different matters. But here force of cohesion is more between the two similar or in between the same molecule. So what is the exactly difference between the cohesion and the addition? Cohesion is the attraction force between the molecules of the same substance. Cohesion is the attraction force between the molecules of the same substance, whereas the addition is the attraction force between the different molecules. And intermolecular attraction is more. Okay, in the cohesion, the intermolecular attraction is there, and here addition intramolecular attraction is there. What is the meaning of inter? Means between the same molecules. Intermolecular force of attraction means between the same molecules, just like these two blue color brothers. And here intramolecular attraction means between these two, correct, just like a green atom and the blue atom. Here you can see addition force is there between the two different molecules. That is known as a intramolecular force of attraction, or where it is present in the addition. includes van der Waals forces and hydrogen bonding. And addition includes electrostatic attraction. Cohesion, the formation of water droplets on the surface tension of a liquid is due to the cohesion, and the spreading of liquid on the solid surface is due to the addition. So now today we are learning about the three states of matter and their distinguishing properties. Okay, here with these diagrams, molecular arrangement, the particles in the solid are closely packed and arranged in a regular structures. They are arranged in a regular structure, and the intermolecular bond is very strong in the solid state, which is strong in the which state? Solid state. Correct, students. Now, in the liquid states, the particles in the liquids are slightly less. You can see here is a more space in between the molecules. So the particles in the liquid are slightly less close packed, and there is some structure. The intermolecular bonds are strong. Okay. Now in the gaseous state, the particles in a gas are spread out. The intermolecular bonds are weak. They are having more intermolecular space. That's why their intermolecular force of attraction is very weak. So they are having a less intermolecular bond. As particles gain energy, they can either increase their kinetic energy and vibrate more. This leads to the change in the temperature or break their intermolecular bonds. And this is known as a change of state of matter. This concept we are learning okay today in the next page. Differences between the solids, liquids and gases according to their properties. Solids, liquids and gases are having their properties. And what is the difference between them? Solids are rigid in comparison to liquids and gases. Liquid is not so rigid. Gases are also not rigid. Solids are having a definite shape and volume, whereas liquid is having no definite shape but having definite volume. Gases. Gases neither definite shape nor definite volume. But in solid states, solid particles have low kinetic energy. Liquids, liquid molecules have intermediate kinetic energy, whereas the gases possess very high kinetic energy. Solids cannot be compressed appreciably. Liquids can easily be compressed. Gases can be compressed easily to some extent level. Their molecules are held rightly by strong nuclear forces in solid. In liquids, molecules are held tightly at an intermediate level. Gases, very weak attraction forces are present among the molecules of gases. In the solids are present in a very dense form. Liquids, density is present at intermediate level. Gases possesses very low density. Solids cannot flow easily, known by flowing property. Flows, gases, flows and evaporates easily. Solids, the diffusion rate is very low, and in liquids, the diffusion rate is moderate. Whereas in the gases, diffusion at a very high rate. Okay, now these all are the properties and the differences of solids, liquids and gases. Now what is the kinetic theory of matter? As we know, every matter is made up of atoms and molecules, correct? According to the kinetic theory of matter, molecules and atoms of a matter are in a continuous motion. Okay, they are in a continuous motion. For example, Okay, suppose, okay, if we put a drop of ink into the water, the molecule of ink get mixed with the molecules of water and soon the water becomes colored. Why? Before water is colorless, but as soon as I added red ink color into that water, then it becomes red. Why? Because of the kinetic motion of the molecules. Means the molecules which are present into the ink, they are mixed into the water, and they occupied entire liquid. As soon as their color is getting changed, this continuous motion of particles is known as kinetic theory of matter. So what is the definition? The continuous motion of a particle is known as kinetic motion of the molecules. Okay, so what are the according to the kinetic theory of matter? What are the postulates of the kinetic theory of matter? Because all particles of matter are in motion, they all have kinetic energy. The higher the temperature, the faster the particles move. At the same temperature, more massive particles move slower than the massive ones. Here with the activity we can see, here you can see this is a liquid. Okay, water. Here we are applying heat to the water molecules. They are absorbing heat, okay, and they are widely spread all over. Okay, means when the molecules absorbs the heat, their kinetic energy is increasing. So kinetic energy equal to half mv square is directly proportional to T. Means what? M is the mass, V is the velocity, and T is the temperature. Matter is composed of small particles. Which are small particles? Atoms and molecules. Now the molecules of a substance are in constant motion. Thus the all substances possesses kinetic energy. This motion is different, okay, in the three states of matter. Thus the amount of kinetic energy possessed by the molecules of three states of matter is also different. Get it? Now, the kinetic energy of the molecules gets affected by the temperature. We have just observed with this activity, okay, before the molecules are in motion, but constant motion, very slow motion, massive motion. But as it absorbs the energy, its kinetic motion is increasing. The movement between the molecules are increasing. So means what happened? Hence, we can understand if we increase the temperature of the substance, the kinetic energy of its molecules also increases and vice versa. Thus, we can say that kinetic energy is directly proportional to the temperature. Hence, what we can say, the kinetic energy is directly proportional to the temperature. So we can conclude this formula: kinetic energy equal to 1 by 2 mv square is directly proportional to the T, and m represents mass, v represents velocity, whereas T represents temperature. Okay. Energy contained in the three states of matter. Energy contained in the three states of matter: solids, liquids, and gases. These are the three states of matter, students. Correct. So, energy possessed. What we are learning today? Now, energy contained in three states of matter: solids. What is the effect when they possess the energy? Solids, the molecules of solids are very tightly packed, so they cannot move to other position, but they can vibrate only, correct? But can only vibrate about their fixed position. Thus, they possess the least amount of kinetic energy. They are closely packed. Solid, in the solid state, The molecules are very closely packed, that's why they can move about their fixed position. Thus, they possess the least amount of kinetic energy. Now, in the liquid state, the molecules of liquids are less tightly packed. So, movements of the molecules within the liquid is possible. That's why whenever you will feel, okay, the water fell on the floor, it spreads, it occupies more area. That is, the position of the molecules are not fixed. Thus, they possess more kinetic energy than solids. Okay, what is in the gaseous state? The molecules of gases are separated from each other by wide spaces and very loosely held. They are in continuous motion and move around independently, thus they possess the most kinetic energy. Okay, our next concept is change of state of matter. Change of state in matter, okay, which is the liquid which is present in the three states of matter. Water. Water is available in solid, liquid as well as gaseous state. Solid in the ice cube, liquid as a water and gaseous as a vapor. Correct. So, the change of state in matter, the process of substance from one physical state to another at a definite temperature is called a change of state. Understand, students? The process of substance from one physical state to another at a definite temperature is called a change of state. So, we can understand the melting, freezing, boiling, condensation, sublimation and deposition. All these processes are involved in the change of state in matter. Okay, one by one we will learn all these processes. Melting or a fusion, what is the first thing is a melting process. First is a melting process when the solid changes to the liquid state by absorbing heat at a constant temperature is called melting, and the fixed temperature at which a solid changes into a liquid is called its melting point. It's called its melting point. The melting point of a pure ice is 0 degrees Celsius. What is the melting point of a pure ice? Is 0 degree Celsius. Now the freezing process. The freezing is the process during which a liquid changes into the solid state at a constant temperature by releasing heat. What is the freezing? The freezing is the process during which a liquid changes into the solid state at a constant temperature by releasing heat. And the fixed temperature at which a liquid changes into a solid is known as its freezing point. The freezing point of a water is 0 degrees Celsius. Now the vaporization. The process in which a liquid changes into the gaseous state is called vaporization. Okay, the process in which a liquid changes into the gaseous state is called vaporization, and this vaporization process is followed by two more processes, that is the evaporation and the boiling. There are two ways in which a liquid changes into the gaseous state, by the evaporation process and the boiling process. So tell me, what is the evaporation? Evaporation is a slow and gradual changes. First, before going towards the evaporation and boiling, we will just go through one activity, that is melting, to demonstrate the process of melting. Here, what the material is required for the process of melting? some crushed ice, a beaker, thermometer and a Bunsen burner. So take the crushed ice in a beaker and note its temperature. This is the melting point of ice. Heat the ice. What we have to do? We have to apply the heat to the ice. The ice will start melting. Then we need to record the temperature, at which point after some time the whole amount of ice will get converted into the liquid. So what you will observe? You will observe that the temperature will remain the same till all the ice melts and is converted to the water. What we have concluded from this, when some solids are heated by absorbing the heat, they converted into the liquids. So just we will go through a quick exercise. Choose the correct options. In melting, solids converts into a liquid. Correct. And freezing point of water is 0 degrees Celsius. Which of the following possesses maximum amount of kinetic energy? Gases. Very good, students. Now we will stop it today. In the next session, we will continue the next processes of change of state of matter. Goodbye, students.